welcome. This is going to be our homework helping video for the probability test review. Let's go ahead and get started with problem number 1. So we need to represent the sample space using set notation. A pizza stand offers both hand-tossed and pan pizza. Each pizza can be either white with no sauce or red pizza with sauce. So we need some variables here. We'll say H for hand-tossed, P for pan, white for white pizza, R for red pizza, or W for white pizza, R for red pizza. We're going to use this curly bracket, and then we got to make sure we get every combination possible. So I'll do the H with the W, then I'll do the H with the R. Now I've run out of toppings for H, so I switch to P. So P with the W and P with the R, just like that. And we got them all. All right, let's do problem number 3. Find the number of possible outcomes in the sample space. So a bagel shop has 3 types of bagels, plain onion and raisin. Each bagel can be ordered with no spread, butter, or cream cheese. So this is our fundamental accounting principle that states that you can multiply these two numbers. Together we have 9 options. All right, chess club's deciding when to meet. The possible days are Tuesday, Wednesday, Thursday. The possible times are 3 or 4. Do you see how there are 6 different combinations there? Hopefully. List all the permutations. All right, I'll do the one with the letters, let you guys have fun with the one with the shapes. A, B, C, D, taken 3 at a time. In permutations, order matters. All right, and so I want to be logical about the order that I put these in. So I'm just gonna go A, B, C, and then A, B, D. And now that I've run out of every combination with an A, B, now I move to A, C, D, and A, C, B. Now that I've done all of those, then I bring the D into that third spot, A, D, B, A, D, C. Okay, so these are a little bit backwards if I was following my order, but as long as I get them all, it's okay. And now that I've done every combination with an A in the first spot, I repeat with a B in the first spot. So BAC, BAD, BCA, BCD, BDA, BDC. Now I try it with a C in the first spot, CAB, CAD, CBA, CBD, CDA, CDB, and now with the D in the first spot, DAB, DAC, DBA, DBC, DCA, DCB. All right, and this is 4 by 4 by 4 by 4 by 4, so 4 times 6 for a total of 24. Let's see, what is 4P3? 4P3 is 24. All right. Evaluate each expression. 7P4. So let's talk about the actual formula to evaluate this. You would want to do 7 factorial divided by 3 factorial. It's always 7 minus 4 factorial, so 3 factorial. So 7 factorial over 3 factorial, which this simplifies to be 7 times 6 times 5 times 4. Then we cut it off. So 7 pick 4 is 840, and 7 times 6 times 5 times 4 is 840. So a couple different ways to get there. What's the number of unique permutations of the letter of each word? So look for double letters. angles doesn't have any double letters. So we can just do 1, 2, 3, 4, 5, 6 factorial. And we get our answer. 6 factorial is 720. But what if there is a double letter? So, or maybe multiple double letters. We'll do minimum. So 1, 2, 3, 4, 5, 6, 7 factorial ways to rearrange those letters, but you got to get rid of the ones where duplicate letters land in the same spot. So I've got 2 I's and 3 M's and no other duplicates. So I put a 2 factorial and a 3 factorial on the bottom here. All right, 7 factorial divided by, in parentheses, 2 factorial, which is just 2, times 3 factorial, which is just 6. And yeah, there's 420 unique permutations. That word unique, very important there. Because if we swap 2 M's, we didn't find a unique permutation. Okay, evaluate each expression. 23C4. So this is going to be 23 factorial divided by 19 factorial times 4 factorial. So you split that 23 where this tells you, and they both get a factorial. So you could split into a 19 and a 4. They both get a factorial. This would simplify to be 23 times 22 times 21 times 20 over 4 times 3 times 2 times 1. The 19 factorial can cancel out with everything after the 20 and the 23 factorial. And let's try plugging this in. So 23 times 22 times 21 times 20. Divide that by 4 times 3 times 2. Get 8,855. Let's just try plugging in directly. 23, choose 4, and I get that same number. 8,855. Okay. State if it involves permutations or combinations, then find the number. So team's choosing 15 players, needs to choose 3 players to refill the water cooler. Does order matter? No, this is a combination. So you would do 15, choose 3. 15, choose 3 is 455. 16, there's 80 politicians at a meeting. They each shake hands with everyone else. How many handshakes were there? So each handshake takes 2 people, but order doesn't matter. So it's going to be 80, choose 2. The number of ways to choose 2 people to shake hands out of 80. So 80, choose 2. There were 3,160 handshakes. Man, that's a lot of handshakes. Don't do that if you're sick. Number 17. Okay, this one is a permutation. So she's got homework in 5 subjects and she needs to decide what order to complete them in. So she's got to do 5, pick 5. All right. So 5, pick 5 is 120 different ways that she can order them. All right, find the probability of the event. Got a couple more pages. Okay. Mechanic. He requires 3 different size wrenches, which has got 8 different. He grabs 3 of them at random. What's the probability that he got all the ones that he needs? So there's one way to grab them correctly, combination wise, out of 9, choose 3 different ways to grab 3 wrenches. So 1 divided by 9, choose 3. This number I'm going to multiply it by 100% times 100%. Oh wait, it's an 8. Gotta redo my calculation. There's 8 wrenches. 1 divided by 8 choose 3 times 100. I get a 1.7% chance. Okay. Jessica and Eugene each purchase 1 raffle ticket. A total of 7 tickets are sold. What's the probability that Jessica wins the grand prize and Eugene wins the second prize? So this one's a little bit different. Jessica, it's not just a combination of them both winning. Jessica has to specifically win the grand prize, which is going to be a 1 in 7 chance. And then Eugene needs to win the second prize, which is a 1 in 6 chance at that point because the grand prize is already gone. So 1/7 times 1/6 times 100% at 2.38. Oh, right there. All right, basketball player has a 50% chance of making each free throw. What's the probability that the player makes exactly 4 out of 6 free throws? So what we need to do is the probability of any single event is 1/2 to the 6th. But how many ways can you make 4 of 6? So we're going to do 6 choose 4. This order doesn't matter. Make, it's not like the first make can go anywhere other than the first one that we actually make. So it's a combination. Makes are not unique. All right, so we've got 0.5 to the power of 6 times 6 choose 4 times 100%, and I got times 100%. I got option A, 23.438%. Okay. 6-sided die is rolled 10 times. What's the probability that the die will show an even number exactly 7 times? So exactly 7. So we have a 1/2 chance of showing an even number. And again, I'm going to raise it to the power of 10, not the 7, because every outcome is either even or odd. And so every unique outcome has this % chance of happening. Now I just need to multiply by the number of ways it can happen. So that's going to be a 10 choose 7 times 100%. So 0.5 to the 10th times 10 choose 7 times 100. I got 11.718,719. There we go. Okay, 23, a little bit different. Now we've got this at least. So we had 7 true false questions. A student forgot to study guesses randomly on every question. The question that they got at least 2 correct. So what we're going to do is, what's the probability that they got none? None is pretty easy to figure out. It's just you got to miss every single time. So it's 1/2 to the power of 7. So each one you had a 1/2 chance on. Cursor stopped working there for a second. All right, now what's the probability that you got exactly 1 right? So it's still 1/2 to the 7th for each unique possibility, but now this gets to be multiplied by a 7 choose 1 for the 7 different ways you can miss 1. And that we can stop calculating there, because when it says at least 2, it's going to include 2. So we're going to calculate none and 1, and then we'll subtract from 100. So none is 0.5 to the power of 7 times 100% is a 0.78% chance. And then 0.5 to the 7th times 7, choose 1, is just going to be a 7, times 100% is 5. Yeah, we'll go to 2 decimal places. 5.49%. Let's add that to the 0.78%. And we get a 6.24% chance. It's not one of our answers because this is the probability of getting none or 1 correct. So you have to do 100 minus that to get the probability of getting 2 or more. So 100 minus second answer is 93.75. That's what I got. And that's exactly what option C says. All right. Adam is carrying 5 pages of math homework and 4 pages of English homework. Gust of wind blows them. And he recovers 4 random pages. What's the probability he recovers at least 2 pages of his math homework? So, what's the probability he got none of his math homework? Well, the probability that he got none of it, let's see, it's 5 of math, 4 of English, so we'd have a, let me make sure I'm doing this right. I'm going to underline my numbers. We got 5 of math, 4 of English, and he recovers 4 random pages. What's the probability he recovers at least 2 of his math homework? Okay, so we're going to say to get none, he would have to go, the first one he grabbed has a 4 in 9 chance of being not math, times a 3 in 8, times a 2 in 7, times a 1 in 6. All right, and then what's the probability you got exactly 1? So we can just pick a random spot to pick up the math homework. So we'll say we picked it up first. So we have a 5 and 9, and then it becomes a 4 and 8 that he got English, 3 and 7 that he got English, 2 and 6 that he got English, plus this one gets to be multiplied by 4 choose 1, or just 4, for all the different spots in the order he could have grabbed his math homework. All right, let's calculate both of these. First one was a 0.8% chance that he got none. This one's going to be quite a bit higher. 5 times 4 times 3 times 2 divided by 76 times 100. So this is giving me a 3.96% chance. Doesn't look like those numbers are high enough. Let me pause the video and think about this one for a second. Okay, I was doing it right. I just forgot to actually multiply by this 4 choose 1. So that means that this number was a little bit too small. It needed to be 15.87. Add these together. So I'm going to add that to the 0.8. I get 16.67, but this is the probability they got 1 or none of his math homework, so we subtract that from 100. 100 minus 16.67, and we get option C. Okay, let's just do 25 or 26, because that one was a little bit of a struggle. We got 6 black buttons and 4 brown. If 6 buttons are picked at random, what's the probability that at most 4 of them are black? We've got 6 black and 4 brown, and then we're going to pick 6 of them out at random. What's the probability that at most 4 of them are black? So what we want to do is figure out the probabilities that we got 5 black and 6 black, and then we'll subtract from 100. So what's the probability that we picked 5 black? Well, we had a 6 and 10 chance, followed by a 5 and 9, followed by a 4 and 8, times a 3 and 7, times a 2 and 6 chance of getting those 5 black. And then the remaining brown button, there was 4 of them of the remaining 5, but that 4 didn't have to occur right there. This denominator is going to be the same, but we have 6 choose 2 different ways, or 6 choose 1 different ways of when we pick the brown button. And then for the 6 black, it is exactly like this, but then it goes down to 1 over 5. But that is just the same as doing 6 pick 6 divided by 10 pick 6. We would get exactly that, but with a 1 there. Okay, let's calculate these. So I've got 6 times 5 times 4 times 3 times 2 times 4. 2 times 4 divided by, that's the same as a 10 pick 6. And I multiply that by 6 choose 1. So we're getting 5 black had an 11% chance. Getting all 6 black is 6 pick 6 divided by 10 pick 6 times 100 is a 0.4% chance. Add those together, we get 11.4, subtract it from 100. So 100 minus 11.4, it's 88.6. And I don't see 88.6. I'm thinking that it was just a rounding error. And this is our correct answer. Let's see with 26. What the correct answer is supposed to be, 26B. So yeah, probably just rounded this 11% a little bit too much. And that's what I should have gotten. Okay. Determine if events A and B are independent. So if they're independent, then they shouldn't multiply to be this here. So I'm just going to try multiplying them. 9 times 3 over 20 times 10 equals 27 over 200. So yes, independent. My guess is these ones will not be, and just looking at it, they're not. Determine if they're mutually exclusive. For this one, we add them together, see if they add to be this probability. 3/4 plus 1/2, that's going to be 5/4, which is not this. So this is no, not mutually exclusive. Let's see if these ones add up. This is the same as 8/20 plus 7/20 equals 15/20, which does indeed simplify to be 3/4. Equals 3/4. So yes, these ones are mutually exclusive. Okay, a few more probabilities. We can do this. So a box contains 4 milk chocolates and 5 dark chocolates and 5 white chocolates. You select a chocolate. What's the probability that it's milk or dark chocolate? So we had 4 and 5 for a total of 9 out of a total of 14. There it is. That one wasn't too bad. Magazine contains 13 pages. You open to a random page. The page number is 2 or 11. So there's 2 possibilities out of 13 outcomes. There we go. Try to put those super easy ones in there. A bag contains 3 yellow jerseys numbered 1 to 3. The bag also contains 6 purple jerseys numbered 1 to 6 You pick a jersey, it is yellow or has a number less than 3. So we just include the 3 yellows without even thinking about their numbers. But for the purple ones, how many purple ones are less than 3? There's 2 of those, and then add up the total number of jerseys. So 3 and 6 is 9. So I get 5/9. All right, and then there's 6 nickels and 7 dimes in your pockets. 5 of the nickels and 4 of the dimes are Canadian. The others are US currency. You pick a coin from your pocket. It is a dime or it is US currency. So you have the 7 dimes plus we need to add in the US currency that's not dimes. So 5 of the nickels are Canadian, so 1 of the nickels must not be Canadian, out of a total of 6 plus 7, 13, so 8 out of 13. There we go. All right, do I have any more problems? Nope, we'll call that good for this one, and have a good rest of your day.